Hi, my name is Tim Lindquist. I'm a professor and chair of the software engineering programs, which are housed within the School of Computing, Informatics, and Decision System Engineering in the Fulton Schools of Engineering at Arizona State University. And I'd like to spend a couple minutes describing for you and introducing you and welcoming you, I hope, to the software engineering programs that are offered by, we call it SIDSE, School of Computing, Informatics, and Decision Systems Engineering. And I'd like to say just a few words about SIDSE before I describe more about the software engineering program. SIDSE is housed on both the Tempe and the Polytechnic campuses, and it encompasses the computing programs as well as industrial engineering programs that are offered by Arizona State University. And it is a highly regarded school, several national rankings of different programs, and it's comprehensive in the different programs that it offers. We offer computer science, computer systems engineering, or a computer engineering program, industrial engineering. We also offer informatics, engineering management, and software engineering. So I'm in charge of the software engineering program, and that's the focus of this introduction and welcome. But before I talk more about the software engineering program, I'd like to relatively position software engineering with computer science, because many of the students who enter the software engineering program have a decision to make of whether they want to do computer science or software engineering. So what's the difference? Well, the difference actually is in the name, and it's reflected in the program and the course of studies as well. Computer science is a science in that, in fact, it explores the scientific aspects of computing, where software engineering is an engineering program which is aimed at being a maker, being a doer of actually doing software construction, engineering software according to an industry prescribed set of standards and guidelines that embody what's necessary in order to create very large scale and comprehensive software systems. Not that computer scientists don't learn how to develop software, they do, but the primary focus of a computer science program is much broader, looking at the foundations of computing, also looking at other aspects relative to computing in society today. Scientific aspects of it, I think, is probably a good way to describe it, where engineering and software engineering is much more concerned with let's do it sort of thing, and what are the best practices, tools, and so forth for developing large-scale software systems. So, let me give you just a quick map of the curriculum in the bachelor's program. We offer both a bachelor's and master's program in software engineering. In addition to that, we offer a program that allows students, when they finish the bachelor's program, to go directly to the master's program. The primary components of the curriculum itself are math and science. As an engineering discipline, there's a year of mathematics and laboratory science that are the foundational aspects of the program. And then there's also, very similar to computer science, the computing fundamentals, which are the very basis of software construction. We then also have software engineering, and this program has been designed to be a highly engaging and hands-on, laboratory-rich program, and consequently we provide the software engineering content through a spine of software engineering courses. We call it the software enterprise. Every semester, beginning in the sophomore year through the senior year, students are involved in this spine, project-based spine. It becomes increasingly team-based, so that by the third year in the program, students do almost all their software enterprise activities in the context of a team, which is very reflective of the way things are in the software engineering industry today. And as a part of those team activities, we infuse the content of software engineering. So we have 3 years every semester. In addition to those 3 years, the last year, it's kind of a double duty. There is, in addition to the software enterprise, Additionally, there is a software project or a culminating experience where as a team, students generally work with someone from industry who has conceived a problem relative to their company and do a full-scale development through that entire year, which is a culminating senior project area. So we also have as a part of the program a focus area, two different focus areas, a primary focus and a secondary focus. The accreditation requirements for software engineering require that students are exposed to at least one application area, and we have chosen 3 different application areas. The students pick one of those 3 as their primary focus. We offer embedded systems, graphics and video game development, and we also offer web and mobile. So embedded systems are kind of where the rubber meets the road, I think is probably the right way to put it, where hardware and software meet. My favorite example of that is an automobile. Today, a new automobile, fully optioned, may have over 300 million lines of software in it. Where 30 years ago there probably wasn't any software in an automobile. Today it's that comprehensive, controlling almost every aspect of the automobile. That would be considered an embedded system because we have some kind of a mechanical system and there are sensors and controllers and actuators and so forth that are computer controlled. And those are the embedded aspects or the embedded processors within that physical system. Lots of other examples besides an automobile, but that's what embedded systems are all about. Graphics and video game development is, I think, what you might expect, doing graphics processing, looking at graphics processors and the graphics pipeline, and also looking at game development, game design, and game engine actually is one of the topics that's covered in that focus area. And then the final area on web and mobile actually looks at exactly that, web applications and also mobile applications. Web applications have an extensive amount of software to their back end, and this focus area goes into that in great detail. It also goes to design aspects of web, but focuses more on the software and on the back end, and also looks at mobile application development on the common platforms now today, which are primarily Android and iOS. So students pick a primary focus area, one of those 3, and then they may pick a secondary focus area. The secondary focus area can be, frankly, anything that you want. It could be another one of these 3, or it could be business, or it could be golf, could be whatever you want. Generally, we ask students to think about what they'd like to do from an educational and a career perspective, and to pick a secondary focus area that supports their career or educational objectives. And then the final area of the program is general studies, and that provides a well-rounded education, looking at the social sciences, cultural awareness, critical learning skills, and so forth. So those are the 5 primary components of the bachelor's program in software engineering. We offer this program in 2 different modalities. One is face-to-face, where you meet in a classroom for almost all of your courses. There may be a couple of courses which are available, what we call it as an I-course, so it's online or a hybrid course. The second modality is online, through ASU Online, which is now called EduPlus. We offer an entirely online version of this program where all of the coursework has to be taken online. Students are not allowed to go back and forth between those 2 different modalities unless they literally switch from one to the other and continue and complete in the other. So once you become an online student, then in fact you take online courses. You cannot mix the 2 different approaches. So that's kind of an encapsulation of the curriculum that's behind the program. It distinguishes itself from typical computer science programs by this software engineering spine that is the last 3 years of the program, every semester in those 3 years. Where in a computer science program, many of the other aspects of the course might be course of study may be the same, but we focus, instead of one course in the computer science program on software engineering, we actually have one course every semester over 3 years that focuses on software engineering. And in those you learn, in those courses in the software enterprise, You learn a measured process, how to assess a process, how to do defect analysis, look at software reliability, software processes, project management, software design, software architecture, several different aspects we go into in great detail, looking at the literature and industry standards for designing software which is in line with today's approach. So let's move on. Actually, I want to talk a little bit about some of the background and other facilities are available. One of them is the faculty. We have a very, I think, highly qualified faculty that deliver the program in both modalities. We have 3 lecturers. We have 6 assistant professors, 1 associate professor, and 2 professors. One of them is me. In fact, they are all located at the ASU Polytechnic campus in East Mesa. Our face-to-face is offered at the Polytechnic campus only. It's not offered on the Tempe campus. And all of the faculty are actually available for face-to-face and online students. And in my view, that's an important aspect of doing the undergraduate education, is to get involved, to get to know the faculty and to learn from them on an individual basis. And we strongly encourage that. There are many other facilities that are available for us. If you go to the SIDC, School of Computing Informatics and Decision Systems Engineering website, you'll find several pages that focus on software engineering, describing in more detail the BS program in software engineering, as well as I mentioned the accelerated 4+1 that gives you both the bachelor's and the master's. As well, and other resources that are available from that website. One of them I want to mention is advising. For the students who, well, it doesn't matter whether you're an online student or whether you're a face-to-face student, you will have an academic advisor, and advising is an important aspect. You're encouraged to take full advantage of advising. There are several pages on the SIDC website that describe for you the processes for advising, for making an appointment, and so forth. For those that are online students, these are separate from the coaches or mentors that are available through ASU Online or EduPlus. These are all employees of SIDC, and their profession is advising, and they can help you focus on every aspect of successfully getting through the program and getting the most out of the program. So in particular, actually there's a link here that shows the different advisors, and I thought it'd be good to kind of show you those. So this is undergraduate advising, so if you students who take the master's program, there's a separate set of advisors, but Susan Borgers is the coordinator for our advisors at the Poly campus. The ones that I'll point out are particular ones who are housed at the Polytechnic campus and deal with the software engineering program. Kirk Hagen also is an advisor of the software engineering, as well as Vanessa Lucero and Yvette Smith. So they are full-time, full or half-time advisors who are available for all the students in the program, both online students and face-to-face programs in the software engineering program. And now I want to spend just a couple of minutes kind of by way of motivation. Why would I do this? Why would I take a program of study in software engineering? The expectations, frankly, are quite demanding for the program. You'll find that that all of the courses in the discipline itself actually require a substantial amount of outside work from the student. A lot of it is software development, but there's other aspects of it as well. And it's good to understand that, in fact, coming in, that is going to be the situation, but realize that it's aimed at providing you entrance into what should be a very lucrative career in software engineering. So here's a page that in fact has several different resources for it related to computer science and software engineering. But in particular, I actually want to take a look at one of those, which is done by the Bureau of Labor Statistics. And this is a characterization of software developers So the Bureau of Labor Statistics publishes and updates on a very regular basis an occupational outlook handbook. And so this covers thousands of different occupations, one of them being a software developer. It's very common for a graduate of a computer science program and a graduate of a software engineering program to take on the position title of software developer as the first job after completing the program. And this kind of characterizes that career. It gives you a characterization of several different aspects of it, what software developers do to earn a living, what the work environment is like, how to become one, the education that's necessary. It also characterizes the pay and compares it with other programs. You'll see that both from the perspective of pay and job outlook, it's a very optimistic view. It's a discipline that's growing and actually growing very rapidly. Many times we hear from industry that they're not able to hire as many software developers as they would like to, and consequently that helps boost up the pay and so forth. And then there's this summary page that actually gives a kind of a high-level description of what software developers do. So in fact, I hope that that's not the only motivation, but if you do decide to become a software engineer and take the course of study at Arizona State University, I think you'll find that it's one that can lead to a very profitable career in software development. We actually work very closely with several local industry and also more at a national level who recruit our graduates, and in fact, there are internships and other, as I mentioned, the capstone sequence and so forth, where teams work with folks in industry. It's not at all uncommon for members of a team in their senior year to be recruited by the company for which they're doing their capstone project. They don't get paid while they're doing the capstone project, but it is a very good way for industry to identify potential talent. And when there is a high demand in the field, their industry is looking for every way that they possibly can. So I hope you will pursue further looking into the software engineering program, take advantage of the resources that are available on the SIDC site. And if you have any questions, please feel free to contact either me or any of the advisors as well. And I look forward to welcome you on campus. Thank you.